Hi, welcome to my second video lecture on analysis of algorithms. In this class, we are going to discuss about the asymptotic notations, worst case, best case, and average case analysis of an algorithms. Asymptotic notations. The performance of an algorithm is measured in terms of the storage space and the time taken for running the algorithms. So, the performance of an algorithm depends on two factors. One is the storage space, that the memory required, and the time taken for executing it. But this time taken will be different for different inputs and it varies with increase in size of the input. So asymptotic notation is the way of analyzing the performance of an algorithm in terms of the input size. So we can call asymptotic notations as a mathematical tool to represent the time complexities, and it is directly proportional to the order of growth of the input. So as a nutshell, the idea of asymptotic notation analysis is measure the efficiency of an algorithm and to find the time taken by the program to execute. Suppose if you want to compare two algorithms and find out which one is the best, we'll execute both the algorithms and the time taken by the algorithms are not noted. Whichever program has taken less time, that will be declared as the efficient algorithms. Now, the three asymptotic notation used to represent the time complexity are theta notations, big O notations, and omega notations. First, we'll see theta notations. So, the symbol for theta notations is this. So, if f of s is a function of theta of g of x, then the value of f of x will lies between the value of c1 of g of n and c2 of g of n, where c2 of g of n is the upper c1 of g of n and c2 of g of n is the upper and lower bound of the functions. Now the value of the function f of n will lies between the upper and lower bound. So that is why we will say that the notation defines a function between the upper and the lower level. Next is the big O notation. Now this big O notation defines the upper bound of the algorithms. Suppose if f of n is a function of big O of g of n, then the value of the f of n will lie below or it will be lesser than the value of g of n, where here it is shown in the figure, shown in the equations that f of n will be lesser than c of g of n, where c is a constant and it will be a positive value. Next is the omega notations. This notation defines the lower bound of the algorithms. See, if f of n is a function of omega of g of n, then the value of f of n will lie above, will be more than the value of c of g of n. That is, omega is the worst case analysis and it will take more time for executions. Suppose, let us assume that we have two computers. One computer is fast in execution, other computer will be executing slow. Now, let us assume that we have given a linear search in the computer A, which is fast, and a binary search in the computer, which is slow. Initially, when the input size is very small, computer A is expected to give better results and in a very less execution time. And computer B, because it is slow, it will give the results in a it will take more time for executions. But if the size of the input grows or increases, then at one point computer A, even if it is faster, it will give a execution time of this will be very high when compared to computer B, because computer B is going to use a binary search, and when for large number of inputs, binary search will reduces the execution or the searching time. For every iteration it will be decrease for n by 2 values. We'll see all these in the next classes. So binary search will give a better execution, and the performance of this computer B will be better when compared for same inputs. But if the input size is going to be large, computer B will give a better results, and if the input size is going to be small, computer A will be give a better results. So in next, we have completed this asymptotic notations. So we will see what is first case, best case, and average case analysis of an algorithm. Worst case analysis of an algorithm is the upper bound running time of the algorithm. Upper bound is the maximum time it takes for running the algorithm. Suppose we have the array with the set of numbers 3, 2, 6, 8, 23 and 78. And my problem is to find out or search the number 60 in this set. Actually 60 is not present in the set. So what the algorithm does, every time it will first compare 60 with 3, it is not similar. So it will compare it with the 2, it is not similar. So similarly it keeps comparing with all the numbers. Finally it says the number is not present. So this is the worst case algorithm where we are searching for a number which is not available in the list, which will take more time for giving the results. So we call this as worst case analysis. And the next is the best case analysis, and it is the lower bound running time of the algorithm. Lower bound running time is the less time it takes for giving the output. Suppose I have the set of numbers 3, 2, 6, 8, 23 and 78. And my problem is to search for number 3 in the list. Number 3 is present in the first number in the list. So on the first iteration itself, it will say the number is similar and it will say the number is 4. So this is the best case analysis where we are searching for a number which is present in the present is a first number in the list. This is best case. Average case is between the worst case and the best case, where randomly it will be available somewhere in between. So in average case analysis, all possible inputs are taken and the computing time is calculated for all the inputs, and we will go for finding the average computation time by summing up all the calculated values and dividing the sum by the total number of inputs. So this is randomly done. The number may be present as a second number, the number may be present as a fifth number. So it is random. That we call it as an average case. So we have to try with different inputs. Thank you. So we have covered asymptotic notations. We have seen what is the best, worst and average case analysis of an algorithm. Bye.